Okay, guys, what I'm going to do is I'm going to go through the next two problems with you. It's called check permutations in URLify. And I'll just describe to you like what the algorithm does, and then I'll show you the code. The code's in the book, so it's not really like a mystery, but just kind of understanding how it works. So it's given two strings, write a method to decide if one is a permutation of the other. So what they did for this one, I'll just put the solution over here, is they did the following. So they took like, just I don't know, any kind of array here. And they have a string, call it, I don't know, ABC D, right? And then you have another string, let's say A, C, B, D. And then they take the first string and they, they insert the letters at the index of the ASCII code of A. So you have to have your ASCII code table open if you want to follow along with this. I don't think it's, tremendously important, but so capital A would be 65. So what you're going to do, this is going to be an integer array. That's going to be 128 spots, because 128 spots will hold all the letters. We need to hold indices from 65 to 122, so that would do it. So let's just pretend that this is 65, and it's currently 0, so we're going to increment it to 1. Let me do that in a different color. So we'll increment it to 1, okay? That's easy enough. So it's going to be that 66. Let's just say it's 66. And again, this is kind of arbitrary the way I'm doing it. And we can put that to 1, right? And then we'll do C. It's going to be 67. And that's 1. And then D is 68. All right? And that's 1. Great. So the first iteration of the loop, the first loop, is going to basically increment spots. If there's another, like another A, ABCA, so then you'll have 2. You'll have 2 there, okay? And both of these strings are going to be the same length. That's part of the condition of this program. So then we're going to do another loop where we're going to decrement the position. So, for example, we're going to go ahead and we're going to use this array. We're going to say find position A, 65, and decrement it. So this becomes 0. Do that in blue. Okay? Find position C. That's A, B, C. Make that 0. Okay? Find position B. That's 0. And find position D. That's 0. Okay. So I decremented. I'm done. And none of these indices were less than 0. So that means it's a permutation. They're equal. Let's look at a case where that wouldn't be the case. No pun intended. So let's look at an example where you'll have a negative, just so you could see why you do this, okay? So I give you my very crooked lines. So we're going to do the same thing, but this time we're going to take, A, B, C, D, and then we'll take A, B, D, F, okay? So again, we're going to use this string. They're both size 1, 2, 3, 4, right? They're both size 4, which is good. And then that's 65. So let's go ahead and pretend this 65. It doesn't have to be A's and B's, obviously. I'm doing this as an example. So we're going to increment it by 1. Okay. Then we're going to do 66. Increment it by 1. Okay. 67 and 68. Okay. And we'll increment both of these by 1. There was 0, there's 0 and every 0, 0. And then we just add 1 to it. Great. Now let's look at this one. We're going to start decrementing. Again, we'll do that in blue, okay? Decrement means subtract. So A, that's 0. B, that's 0. D, that's 0. Good. And now F. So it's A, B, C, D, E, and then F's going to be over here. So the value in F currently is 0. okay? Because that means we haven't put in a letter there. Now we're going to decrement it, and we're going to get -1. Wait a minute. If we have a -1, what does this mean? That means that this letter F was not in the original string. Therefore, it's not going to work. Therefore, they're not permutations of each other. All right? So that's that's what's going on in this algorithm. It's pretty simple. Let's look at the code. So here's the code. What you do is you create an integer array of size 128. Again, that's to accommodate all the letters, right? Then we make a character array. We set it to, I don't know. This could be anything really. It doesn't really matter. You could just say, you should actually do this. Okay, so just whatever that is, right? This will point to whatever character array. Word1.toChar array, that'll make a char array from word1. For character C, and this is called an enhanced for loop. So basically it's going to iterate over every character and character array and call it C. Int array at C. This is a little tricky. What does this do? This is kind of weird. Let me just explain what that does. Now you're saying, wait a minute. C is a character. How does that work? Well, when you index arrays with characters in Java, it actually converts it to an integer. So we're going to say, let's just pretend in the loop the current character is A. So it's actually going to replace C with 65. So it just does that automatically. Just know that it does that automatically. It will convert it from its character value to its ASCII value when you index it in an array. It's just how Java works. So that's why this right here works. It's going to just, and what plus plus does, it says go to space 65 and increment it by 1. So whatever value is there, just add 1. You don't need this print. I just put it there. I don't know why I put it there. You don't need it. And now you say, well, what does this do? Well, now we're just repositioning the pointer of character array to go through the other word. So originally, char array is a pointer. And it's pointing to this, okay? And then it's going to iterate through. When we're done with that, what we're going to do is we're going to say, hey, you know what? Forget about this pointer. Don't worry about that. And then do this. And then its char array is going to point to this, all right? I'll show you in the debugger after we're done. So we're just resetting the pointer. And then for character C and char array, so in other words, the word 2 characters, you're decrementing each letter. And if we do hit an area where the index, where that particular spot in the array, like for example here was negative, you're going to return false. If I got to here, that means nothing was negative, so it's true. And this will work because the variables are the same length. So let's just quickly run the debugger through just so you can see what's going on here. So if I hit F8, you can see if I go to char array, that's ABCK. So it's pointing to word 1, ABCK, right? And I hit F8, and we're saying int array at C. So C is the character, this is the character. In other words, C at 97, it's just going to fill in the A with 97. We're going to increment by 1, right? So if I go to char array, int array rather, and I go to 97, because that's what the lowercase c is. See, I incremented by 1. So I'm just going to keep doing that. That's 98, that's 99, so on and so forth. Now watch what char array is. So remember I told you I reset the pointer? So I reset the pointer. Char array is now ABCD. It's now what word 2 was, because when I called the function, it's kind of hard to see, but I called it with ABCD. So I just reset the pointer, and it's going to go through and do the same thing. And you're going to notice if you open this up, it's not there yet. So that's, okay, keep going. So we'll keep going here. And then it returns to false because we ended up with a -1 at the index where it did not find k. K ended up with a -1. So hopefully that makes sense. I'm going to end this video. I'll actually do the explanation for the next problem in the next video. Thanks for watching, guys.